Hello and welcome everyone to another session full of action-packed learning. I am Deep Prasad along with Shivam Batra, part of data science team at Analytics Vidhya. I'll be the moderator for this session. For those who have joined the session for the first time, let me give you a brief introduction. Data Hour is a series of webinars conducted by Analytics Vidhya and led by top industry experts. It is a fun way to understand the concepts of data science from the leading players in the tech domain. As the name suggests, it's 1 hour dedicated to data. We are hopeful that these sessions are going to be great source of enrichment and value adding to our community members. Now on to the session of our topic, which is Jumpstart Your Career with AWS AI ML. And I hope you are excited to attend this data hour session within our. Before we kick things off and I hand it over to our speaker, a a quick recap. We are recording this session and will make the recording available in a few days on our YouTube channel. Please use Q&A sections for asking any questions you might have during the session. Also, I'll share the post about the feedback towards the end of the session. I request you all to kindly fill up. Now on to our speaker in this session of Data War, we have Mr. Prem Kumar Rangaraju, who is a senior AI ML specialist solution architect and NLP domain lead at AWS. Prem is also a prolific author, having published 16 ML blogs for AWS, a research paper on reinforcement learning, and an NLP book ranked 8th in the 15th best of NLP books of 2022. Over to you, Prem. A virtual stage is all yours.
Thank you very much, Analytics Vidhya, and thank you so much for the opportunity to be speaking at the Data Hour. And hello and welcome all to our participants and attendees for today's session. I see that we have people from all over the globe, so thank you so much for taking this 1 hour of your time to attend this webinar. I hope we make it worth your while. So what I'm planning, I've got a packed agenda for you today. My objective for today's session is to introduce you to the AIML offerings at Amazon Web Services and walk you through some of the key features and services that can help different personas within the machine learning lifecycle, including data scientists, ML engineers, solutions architects, engineering leaders, technology leaders, as well as business analysts. So that is the objective of today's session. So I plan to initially start off with a slide where I walk you through the key capabilities within AML, within the AWS Cloud Platform. And subsequently, I kind of want to jump into some demos where I will walk you through our SageMaker suite of offerings, as well as walk you through some services within the AI space, which is pre-trained models available behind an API. So I want to walk you through that. And then I also have some resources, learning resources I want to share, which I also want to leave with Analytics Vidhya so that they can share it with all of you. That contains tutorials and quick starts and labs and workshops that you can run on your own so that you can do some self-paced learning as well within the AWS platform. And if time permits, I also want to talk about my upcoming book. Which is based on it's called Cloud Native AI and ML on AWS, and we plan to release it by the end of the year. But I kind of want to walk you through the table of contents as well as a sneak preview of chapter 1 from the book. And subsequently, I do have some fun demos. So it's not all about work hard, play hard, that kind of a thing. It's also about having fun. So how can we have fun with machine learning? So I kind of want to walk you through a couple of demos. So that I presented in our reinvent sessions before. So there is a demo with with something called the simple beer service, and then there is a demo using Deep Racer, which is our reinforcement learning powered autonomous navigation service. So let's see, because I've been given only 1 hour. So let's see how much I can cover within this 1 hour. And once again, feel free to raise your questions in the chat. And I do have I think panelists will keep me informed in terms of questions and stuff like that. I'll see how many questions I can take. But if not, I strongly recommend that you please connect with me on LinkedIn. It's available in the registration page, and you can directly ping me on LinkedIn, and I'll be happy to answer any questions you have or help you with your own career in AIML. So happy to help there. So with that, let me go ahead and get started. So I'm going to share my screen because as I said, we'll do a slide first, and then subsequently we'll get into the rest of the demo. Okay, so I'm going to go ahead and right. Let's see here. This one. Okay. All right. So please do let me know if you're able to see my screen.
Yes,
moderator, we can see a screen. Okay, great. All right, sounds good. Okay, so with that, let's jump right in, considering we have about 53 minutes. Okay, so this slide here is something that so we share with customers and also at Reinvent, etc. So this is a very good overview, maybe a 50,000 or even 100,000 feet overview of the AML offerings at AWS. So if you look at it, we like to think of AML in 3 layers of the stack. So the bottom layer is for advanced practitioners, advanced data scientists and developers who are comfortable building and operating at the frameworks and the infrastructure level. So this is for those data scientists who would like to create maybe their own algorithm packages or deep into research, would like to work with, let's say, the ML frameworks and build their own containers for model training and so on. So we support all the major frameworks, as well as we recently added collaboration for Hugging Face. So you can directly import Hugging Face models into SageMaker and single-click deploy and all that stuff. And then, so we have a broad and deep range of EC2 instances or compute instances, some of the most powerful compute instances in the cloud today for running high-performance ML training, including distributed learning and model parallelism, data parallelism, those kind of workloads. So we support a number of a wide variety of instance families, both CPU and GPU instances. And we also have designed custom chipsets for machine learning inference, which is Inferentia, for machine learning training, which is Trainium. And we also have a partnership and collaboration with Intel, and we support Abana Gaudi processors within the AWS platform. So in the middle layer of the stack right here, we have the ML services layer. And this is where we have, for example, our SageMaker service. SageMaker is an end-to-end machine learning platform. It's a managed service. And it provides you the ability to do detailed deep dive machine learning throughout the entire steps of the machine learning workflow, but without you having to worry about the infrastructure provisioning, the scaling of the infrastructure, or worrying about, let's say, frameworks and stuff like that. So you can, so if you want to, let's say, for example, so you're going through a standard machine learning workflow. And let's see what features that SageMaker offers for a standard machine learning workflow. So if you want to, for example, start with data labeling, we have SageMaker Ground Truth, which provides you the ability to do automated data labeling because there is a machine learning model behind the data labeling framework within Ground Truth, which can learn from how the humans label your data sets and then use that model in an active learning kind of a workflow. So you have Ground Truth for labeling data. You have, for example, if you want to do data preparation, data collection. So we have a number of data wrangling services, including SageMaker Data Wrangler. SageMaker also provides integration with Elastic MapReduce and other services, which help you to, let's say, select, process, collect, transform, and prepare your data for machine learning training. You can use SageMaker Feature Store, which is a cloud-based, reusable ML feature store for you to, let's say, collect your features, prepare your features, store your features, and then store the results of feature engineered data, and then directly reuse those features for ML training. You can use SageMaker Clarify to detect bias. You can use SageMaker notebooks and let's say train in the local mode or train using just the notebooks, run some experiments and trials before you go into an actual end-to-end ML ops. You can train your models in SageMaker. You can tune. You can do HPO, hyperparameter optimization. You have a number of options to deploy your models to production, including setting up real-time batch, etc. You can do explainability. You can monitor your models, detect data drift, also set up an active learning that way. And you can train on the cloud and deploy your models on the edge so that they run on hardware, which are directly running in, let's say, industrial factory flows, etc., for local inference. So that's the SageMaker layer. And we also have certain services that we recently launched, such as SageMaker Canvas, which is a no-code ML option for business analysts. So people who are not interested in ML training or a lot of feature engineering activities, they directly want to take a service, point it at the data and say, hey, go and figure out what's there. Here is what I want to predict. Canvas has the ability to directly go look at the data, run feature engineering, run tuning HPO, and then select an algorithm, train a model, deploy the model, and then provide the endpoint for inference. So it's a complete no-code ML option. Studio Lab it provides you the ability to do free ML training and let's say run your ML workloads free of charge without you having the need to sign into an AWS console. So that's the middle layer, and this is for everyday developers and data scientists. And it's an end-to-end platform. So I'm going to show you a demo of that real quick. But think of it as, all you need is SageMaker for your end-to-end ML workflow, right from you having to look at what data you want to collect from where, right from that place to, let's say, deploying your models and running inference. So you can do the whole thing within SageMaker. The top layer of the stack, these are AI services. AI services are pre-trained ML models. And they've been trained and they're available beyond an API call. So if you want to AI-enable applications, all you have to do with this layer is you make an API call, send a request, and get an inference back. And this layer also provides options to do, let's say, transfer learning or incremental training. So you can take a pre-trained model and with all the weights and everything that it has learned, and you can, let's say, train it for your own custom use case or your custom data to get a unique version or an updated version of that model for your own use case. So you can do that too with some of the services that we have. So we look at AI and specialized and core. So core services are your sensory cognition services, right? Speech to text, text to speech, and so on. And NLP, etc. NLP, NLU, ASR. So if you look at translate, as the name indicates, it can translate text into multiple languages. Comprehend is our NLP service, natural language processing service. It helps you to derive insights from text. Textract is used to digitize documents into, let's say, JSON structures. So it is a OCR service, but it doesn't use OCR. It uses machine learning. OCR is optical character recognition, by the way. Amazon Lex is a conversational AI service. You can use it to build chatbots. Amazon Poly converts text to speech. Transcribe converts speech to text, and transcribe call analytics can derive unique insights from your call transcripts. For computer vision, we have recognition. This is for image classification, for a wide variety of multi-label classification. You can do video analysis, image analysis. You can do celebrity recognition, face comparison, and so on and so forth. Panorama is our a service which allows you to, let's say, add machine learning models to your camera array within, let's say, an industrial setup, so that you can run machine learning inference locally directly from within the context of the cameras. So that's Panorama. And if you look at the specialized services, we have services personalized for personalized recommendations, forecasters for time series forecasting, fraud detection for e-commerce and payment frauds. Lookout for metrics is to do anomaly detection in business metrics. Kendra is our NLP search service. I mean, I don't have time to kind of go through everything in this call, but you kind of get the picture. So there are lots of options out there. So when you are making a choice as to, okay, what layer should I use for my use case? If, for example, a use case is a common use case, meaning that's something that, it's pretty prevalent. It doesn't need a lot of customization. It's something that you kind of want to directly go look at. And for example, it's an image classification or object detection, and those kinds of use cases, commonly used use cases. First, go to the AI services layer, because you probably already have something there that you can directly use without you having to do any ML training. But if you have a highly specialized, highly custom use case, then you should consider the SageMaker layer, because that provides you the ability to, let's say, define your own models. You can build your own algorithms, build your own models, bring your own algorithms, bring your own models, set up training, take it through every step of the ML workflow, tune, deploy, evaluate, and then monitor and active learning and all that stuff. So that's how I would approach it. All right, so with that, I kind of want to quickly pivot now and go and start looking at some of the demos that I promised I'll show you. Right, so let me go ahead and go here. So if you can still see my screen, this is the AWS console. And this section in this AWS console shows you all the services that are out there. And we keep adding services almost on a services and features almost on a very regular basis, daily basis, weekly, monthly basis. And this is what we have so far. And we will launch new services and features at reInvent. And we do launch it throughout the year as well. So if you look at it, it's a lot of stuff that's going on out here, but we are interested in this session, in this category, which is machine learning. And as you can see here, we have a number of services. So some of these services are AI services, and some of the and SageMaker is what we talked about as the end-to-end machine learning platform. Right. Okay. So now that we have this information, so let's go and look at the bottom layer of the stack, which is for advanced developers and practitioners, right? So what choices do they have? For example, you don't want to use SageMaker. You want to spin up your own compute instance. And you want to, let's say, set up that compute instance so you can run machine learning training, because that way you have a very high level of flexibility, because there's not a lot of abstraction. But you got to take care of everything. You want to take care of patching the instance, the upgrading the instance. You got to take care of setting up the environment. You got to take care of, let's say, setting up your containers if you're using containers. So you got to take care of the whole thing, but it does give you a lot of flexibility. So if that is what you want to do, which is the bottom layer, so how do you do it? So in which case, you can refer to this particular URL right here, which is a GitHub repo. And as the name indicates, it says deep learning containers. So DLCs are deep learning containers. So we have custom built a number of containers for supporting a variety of machine learning libraries, as well as frameworks that you can directly use and deploy it into your EC2 instance. And then you can start building your ML workloads, leveraging these containers, and then use your EC2 instances, which is your compute instances, to set up training. So you can do that. So what options do we have available? So just give me 1 second. I'm just try and keep this toolbar here so we can see the whole thing. All right. So if you see here, so we have different frameworks, different versions of the framework. So PyTorch frameworks, various containers. What is a job type, right? It's a training or an inference container. Harvard is your distributed learning framework, right? Harvard was created by Uber. It's a distributed learning framework. It uses MPI. So is Harvard enabled or not? What type of instance, CPU or GPU, or Python version, and what is the image URI, right? So what this means is you can directly go refer to this image URI, pull that in into your EC2 instance, set up your Docker container environment, and start training. So I can do that. So this is kind of like pre-built for you, right? So I would come to this page and look at what options are available if that's what I want to do. So you have PyTorch, you have TensorFlow, MXNet, training and inference containers. And you also have the Graviton container. So Graviton gives you almost up to 25% price performance compared to, let's say, the regular EC2 instances. So if you're a price and, let's say, time conscious, then I would recommend to try and use Graviton containers, because that way you get better price performance. So it supports PyTorch and TensorFlow frameworks. And then you have the SageMaker framework containers with the SageMaker support. Again, you have it for all the major machine learning frameworks and different types of jobs, training, inference, distributed learning, and so on. We have NVIDIA Triton inference containers for SageMaker. So these are specialized containers for optimized for inference. So they're high performance, as well as they'll save on cost as well as time for inference. You also have support for Habana Gaudi processors, training containers, AutoGluon, inference containers. Then you have the Hugging Face training containers, Hugging Face inference containers, Hugging Face Neuron inference containers. So Neuron is Neuron provides the SDK support for what we call as elastic inference. So elastic inference is It provides you GPU burst capacity to your CPU instances whenever there is a lot of traffic coming at inference time. So that's elastic inference. And Neuron is the framework that supports it. And we have working face Neuron container for that. And you also have SageMaker training compiler containers, regular Neuron inference containers, and the prior versions, right? So this is a very good resource. I'll make sure to provide all this to the analytics Vidhya team. So please be on the lookout. I think reach out to them and get all these links, because this will be very useful as part of your ML journey. Right, so that's the container. So what else do we have? At the bottom layer, we can also do what is called as AMIs. AMIs is Amazon Machine Images. So instead of, let's say that you don't want to use containers, you directly want to build machines that are ML enabled within, let's say, your compute instances on the AWS cloud. So you would use something called EC2, which is Elastic Compute Cloud, compute instances. But instead of using a container to, let's say, specify your ML environment, you would directly build that machine using something called the machine image. So think of it as, let's say, an image for your computer, but that image is pre-built with ML stuff, right? So what options are there? So I came to this EC2 console here. I went to launch an instance. I came to the AMI page and I said deep learning. So when I say deep learning, I see all this deep learning AMIs available, right? So you can go directly click on select, and this will then pull this image into the EC2 compute instance that you will launch on the AWS cloud. So that EC2 compute instance is already built using this image. So you can directly go in there, and then you can port your algorithms, start doing your, let's say, entry script if you want to develop that. And you can then set up your environment and start your training, ML training. So using this AMI. So a number of options available out there. So we have certain quick start AMIs. So these are AMIs that you can simply one-click deploy and then get it going. So you can select, if you want to, let's say, look at not only AWS or AWS partner provided, but others, let's say other partners of AWS, not, let's say, hardware or ML partners, but who have ML AMIs that are available. So you can come here. So you have a number of AMIs available from a wide variety of partners that you can directly start using, or you can go to community and you can say, hey, I want verified providers. So you can get AMIs from, let's say, Ubuntu, AWS, and so on and so forth. So you can just scroll through this list to see what you want. But it kind of tells you, okay, so what does this do? It's a TensorFlow. It's got all these packages installed. It's got GP accelerator installed. It's got Docker. It's got all these things, right? So you kind of review that. You select that, one-click deploy, start your EC2 instance, and start model training. So this is at the bottom layer of the stack. Okay, now we come to the middle layer. The middle layer, as I mentioned, is SageMaker. So what do we have there? So if you go back here, what I can do is I can always search for a service here. I can say SageMaker here and pulls up SageMaker. So I select SageMaker and I'm in the SageMaker console right here. And so if you see here on the left, there are a number of options. And these are the options that we saw in that slide there, right, in the middle layer. So what are the various things that you can do? So in this particular thing, there are two ways you can get started with SageMaker on. In fact, there are multiple ways, but let's talk about two ways. Either you can directly spin up a notebook instance within SageMaker. You can create a notebook instance, and then you can directly log on to that notebook instance and start using a number of let's say, built notebooks that SageMaker provides to test out all the features within SageMaker. You can directly use it and start playing with it and then customize it. So that's one way of doing it. So what do I mean by that? So to do that, you go here, click on notebook instances, right? And then, so I got a number of notebooks here. So all these notebook instances, you can say create notebook instance. You can provide a notebook instance name, instance type, and then you say, hey, I kind of want this IAM role. Either I can say like this, select one, I can create a new role. So I can create a new role and say that I want access to any or all S3 buckets, right? And then it creates a new execution role for me. And then I can say create notebook instance, in which case a notebook instance is created. And once a notebook instance is created, I kind of set this up so that we can have a look at it right here. So what you do is, let's go back here. Let's probably take this one here, let's say. Sorry. So once a notebook instance is created, You can go review the notebook instance like I did now, or you can directly click on Open Jupyter. So when you click on Open Jupyter, it opens a Jupyter environment for you within that notebook instance. So initially you come to this particular page here, and when you open a new notebook instance, this is going to be empty. But what you can do is you can go to SageMaker examples right here. And I just want to first collapse it. But as you can see here, you have a collection of Amazon SageMaker sample notebooks. And I mean, literally for every single type of feature that's there in SageMaker, you have sample notebooks and tons of them. So if you look at this one, applying machine learning. So you have, let's say, breast cancer prediction, ensemble learner, churn prediction, DPR, blah, blah, blah. So let's say that I want to select DPR, Chicago traffic violations, right? So let's say that I want to select this notebook. I simply click on, where are we? Here. I click on use. When I click on use, it says, should I create a copy? It says, yeah, go ahead and create a copy. It creates a copy. And it sets up a kernel for me, and I'm ready to go. I can directly start executing this. I can say, go ahead and run and execute this notebook. So that way, I know exactly what this notebook does, and I can learn from going through this notebook. And maybe then customize this to use it for my own use case, right? So if you look at it, so for different applied machine learning concepts, and then here you have Amazon algorithms. All the algorithms that Amazon SageMaker supports as a built-in algorithm. So what does it mean? It means that it already has a pre-built Docker image for that algorithm. You don't have to, let's say, write your script. You don't have to, let's say, do anything. All you have to do is go, select that URI, pull that into a SageMaker environment, and start building, let's say, access to your data, whatever you want to do, feature engineering. And then you can directly go and set up an estimator and fit the estimator, providing your training and evaluation data sets, because the algorithm is already pre-built for you. And so these are the various algorithms that's already supported by SageMaker. And you can directly start using some of these notebooks. For example, I can say image classification, or let's say linear learner, right? So if say use, so this comes up. So this notebook comes up for me. So I'll say, okay, it wants a Python 3. So I'll select a Python 3 kernel, set the kernel, right? And then I can start using it. And if you see here, it kind of explores the data set. It takes you through the whole process, right? Setting up the training input. And here is where it sets up the linear learner estimator, right? And then here, as you can see here, it's retrieving the linear learner image, which is a pre-built algorithm image for this particular algorithm. And you get the container URI, and you pass this container here to the estimator, and then you're set, ready to go. So the hyperparameters fit it, you're done, right? So it's pretty straightforward that way. And I mean, personally, myself, I did most of my learning here by skimming through these notebooks, trying these notebooks, and customizing it for my own use case, seeing how that worked. So I learned a lot by just doing this piece right here. This is one option. What is the other option? The other option is, let's go back here, right? Let's go back to SageMaker. And here we have something called Studio. Studio was launched in 2019 reInvent, but Studio is the first purpose-built integrated development environment for machine learning workflows. Okay, so if you want to do end-to-end machine learning, you can use all of that from within a single IDE, and that is Studio. So if you want to do Studio, you can say click on Studio. You can say launch SageMaker Studio. If you already have, for example, you have a few users here, you can kind of go and select those users, or you can add a new user. And when you add a new user, you can go ahead and say, okay, so what is my execution role, blah, 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 next, and you give some settings, and it adds a new user. Once you add a user, you can launch the Studio for that user. So in my case, what I did was, in order to show this to you, I kind of selected this user right here and clicked on Studio. So when you do that, it sets up a Jupyter server environment and launches this application, Jupyter server application. And within this Jupyter server application, you have all the resources you need to do all you need to do about ML, end-to-end ML. So what do I mean by that? So, so here you have some Jumpstarts. Jumpstarts are a great way to get started. So you have, let's say, for example, let me go to the Jumpstart page, right? So if you see here, for each and every use case, image classification, object detection, text classification, question answering, let's select text classification, right? I can directly go and deploy a model, meaning a pre-trained model, deploy it, run inference and start using it. Or I can train a model, or I can run in a notebook, right? So the advantage of Jumpstart is if you're in a hurry, kind of want to, you have a customer or you have your employer who's like, hey, I kind of want to get this going right away. You go to Jumpstart, select what you want, either do a deploy or do a train, and you're ready to go. All you have to do is point it at the right data set, make sure everything is set up fine from HPO and your algorithm perspective, you're ready to go. Okay, if that's what you want to do. But if you want to learn, really learn, meaning step by step, let me go through the whole thing, then I've got some resources for you. But prior to that, let's come back to this launcher. So here you can use, for example, SageMaker Autopilot, which is AutoML on SageMaker. So you just take Autopilot, point it at your data set, it does everything: feature engineering, hyperparameter optimization, tuning, training, evaluation, deployment, the whole thing. So that's done by Autopilot automatically. And remember, I told you about SageMaker Canvas, which is a no-code ML option that uses Autopilot under the hood, right? So Canvas uses Autopilot under the hood, a point to remember. Okay, so that's in terms of if you want to, let's say, use Jumpstart, if you want to build models automatically using Autopilot. But if you want to, let's say, do feature engineering, if you want to go look at your data set, collect the data set, transform, analyze, feature engineering and all that, you can use Data Wrangler, right? So if you click on Data Wrangler right here, so this is going to take some time to import the data sources, but it kind of creates this initial page right here. And here I can go ahead and say, okay, hey, I want to import my data set from, let's say, S3, for example, right? So I can kind of do this. I can import a data set from S3. So it gives me the list of buckets and I can import the data. So once I import the data, what I can do is I can go ahead and let's say, so in this case, let's use a sample data set. So I use a sample data set. It uses the Titanic data set. It's an S3 bucket. It's got the data in a CSV file. So here I can do lots of things. So when I click on this, I can add an analysis. An analysis is where you can create a histogram, you can create, let's say, understand the data distribution and understand exactly what your data set is so that you can be better informed about what kind of future engineering you want to do with your data set. So you can do analysis. You can also do, for example, let's come back to the data here. Okay, so I can do a step here and I can say add a transform. So add transform, right? That's a step. So first we do the analysis. So we do the analysis, we understand what the data is. Now we are ready to do feature engineering. We want to do transformation. So there are a number of options. Either I can create my own custom script, PySpark, Pandas, etc. Or I can do a custom Spark SQL expression, or I can use one of the pre-built transformers. And Data Wrangler provides 300 plus pre-built transformers for all kinds of what we have seen in terms of what customers do. So based on that, we have built these transformer maps that's already available. So directly one click, deploy it into your thing, point it at your source data, do the transformation, send it back to another S3 bucket, or maybe send it directly. You can also integrate this with the feature store and send it directly to the feature store. You can do that. Okay, so if you look at it here, number of options are available. So many options are available. Yeah, so 300 plus, etc. Now, again, I've just 1 hour, so I don't have the time to dive deep into each and every aspect of it. But I want to quickly point you to this particular resources tab here. So in this tab, what you can do is you can select this list box, and it gives you a number of options to access each and every aspect of the ML workflow and do whatever you have to do. And once you, let's say, build your project, build a Data Wrangler flow, build your feature store, set up a MLOps pipeline, register your models in the model registry, create endpoints, you can then orchestrate them together into a flow and automate the whole thing, right? So for example, let's say that you use GitHub and Jenkins and whatnot. You can, let's say, have your model source code in GitHub. So every time you work on a model, you, let's say, commit the source code to GitHub. From GitHub, you can, let's say, using Jenkins or using SageMaker pipelines, you can trigger, let's say, an automated MLOps flow, which will go pull the data, build the model. It will go look at SageMaker, use the SageMaker training API, train the model, deploy, evaluate, send a notification to a human in a workflow, They look at the evaluation results. The metric looks great. Okay, the model is ready. Let's promote it into production. So you can promote it. You can set up an endpoint, complete the deployment. So you can automate the whole thing. So typically in the experimentation stage, you would use notebooks. You would run experiments and trials to test your models and get the accuracy that you're aiming for. But once that's done, you don't have to, let's say, manually keep deploying and all that stuff. You can directly come here. You can use the pipelines. You can say, okay, set up a model build deploy pipeline. Set up that pipeline, integrate that with your source repository, and then you're good to go. So what do we mean by pipeline, right? So if I come to this, so let's look at this MLOps pipeline test that I had. And if you look at the graph here, so this kind of says, okay, so this was an Abalone data set, pre-process the data set, train the model, evaluate the model, check the evaluation. Yeah, it looks good. Go ahead and register the model, and then subsequently can have steps where you deploy the model, run inference, and so on. So this is a pipelines workflow. And this is MLOps integrated within the SageMaker Studio environment. So in the interest of time, I'm going to quickly jump to SageMaker Canvas. This is the no-code option that I mentioned, right, which uses autopilot behind the scenes. So if you see here, so I can, hang on, so this is expired, so I'll have to, sorry about that. Let me quickly go and launch it once again. So when I launch Canvas there, so it's going to take me to, oh, sorry, I did, let's go to SageMaker once again. SageMaker Studio. I'll go to Canvas. SageMaker Canvas. Come here, go to Canvas. So I can go to Canvas, and so I trained a model here for my book. This was chapter 7, right? So what you do is you select a data set, and then you go to the build. You say, okay, this is the target column I want to predict. In my case, it was a wine data set, and predict the price of wine based on the number of features. This is the target column I wanted to predict. It's a numeric prediction because I'm predicting the price, and this is my data set. It gives you some statistics of your data set, which is really cool. And then when you go into the analyze, it trains a model for you to play with it. And then subsequently, you're good, you can go into the predict phase. So in my case, my RMSE was 23.75. I was okay with it. And it kind of shows you the correlation of the various features, the target feature you want to predict and the impact. So once you're kind of happy with this, you can go into the predict, and you can do batch prediction or single prediction. And in the single prediction, it tells you, so you can provide some values here, and you can submit it, and it tells you what is the price. So you can test it. So you can do the whole thing with Canvas. So no need for any kind of, let's say, feature engineering or training, tuning, deploy. Everything is taken care for you using Canvas. Okay, so this is for business analyst persona. Okay, so that's something that I wanted to show you. The other thing is this thing called the Studio Lab that we launched recently. You can request for a free account. Anybody can do it. Just provide your username and email address. They'll send you a pre-signed link. Click on that link. You get access to an environment where you have a number of hours of GPU and CPU free of charge where you can try it out. So I recommend, if you're interested to kind of get started quickly, I recommend this particular service called Studio Lab. Okay, now that we have done all that, I also wanted to share with you these resources, right? So when you go to the Getting Started page on AWS, it's a really cool page because if you're new to AWS, right? If you have not heard of AWS before, maybe heard of it, but never played with it, this is a very good starting point. So the number of tutorials out here, launching a web application, deploying a container, serverless. You can go to the Developer Center, Architecture Center, tons and tons of resources for learning. And you can also go to machine learning if you want to dive deep, which is this page here. And if you look here, it's got a number of resources here. So what is machine learning? And then read about each of the services, both SageMaker as well as AI services. Read through some of the fundamentals of what each of these services are. And then you have these training and certification resources, right? So you can free training. This is all a digital training free of charge. Log in, get your user ID, and start learning. So it's got tons of stuff here. Please do review this. And it also got this tutorial, right? So if you click on this tutorial, this is something that I would recommend. So once you get your Studio Lab account set up, go to the tutorials page. Number of tutorials for most of the common ML use cases. All it takes is 10 minutes, right? and it's free tier eligible. So you, not only can you do Studio Lab, you can also do, you log into AWS, get an AWS account, you provide your credit card, but up to 1 year, you have a number of items, I mean, a number of services available free of charge in the free tier. So you still don't have to pay anything until you hit the limits of the free tier. And it sends you all the instructions and when you hit the limits and so on. So you can still try all these tutorials out, right? So it kind of shows you how to create a notebook instance, preparing the data, train the model, etc., etc. So I'll send these tutorial resources as well. So please do have a look when you get a chance. And then the other thing I wanted to show you was the architecture page, right? So right here, sorry, this one. So this architecture center. So this is an interesting one because it provides you a number of pre-built solutions as well as reference architectures. So for example, this particular thing is improving forecast accuracy with machine learning. So if you click on this, it actually gives you an implementation guide. It gives you a CloudFormation template, and you're ready to go and build this whole solution in your AWS account, single click. Click the CloudFormation, it sets up the whole thing. It gives you a guide. You can test it out. And then subsequently, if you want to take this and start customizing on top of it, you can do that as well. So that's the solutions page. And you also have architectures, right? So if you do reference architectures, it gives you a number of, for example, let's say, okay, automated time series forecasting with Amazon Forecast. So if you click on this one, it gives you this reference architecture. Step by step, what do you do? Data sources, ingest, prepare the data, use forecast, select a recipe, run the forecast, set up the predictor, and then send the inputs to a dashboard so that you can do visualization and so on. So it gives you that. So I actually really like this particular site here because I mean it's just have a look. Number of solutions, guidance, your white papers, technical guides, whatnot. Lots of free resources to get started. All right, so that's that. What else I wanted to show you? Okay, so the other thing I wanted to show you is this ramp up guide for machine learning. So depending upon, so machine learning is an ocean, as you all know, right? So data science is one person or one aspect of what you want to do. You have ML engineers, you have decision makers, you have directors, you have engineering managers, you have business analysts, number of personas. So if you want to choose a particular persona and you want to establish a career using that persona, how do you get started? Where do you start, right? So this is a very good ramp up guide. It kind of walks you through step by step, every single aspect of machine learning on AWS. And it gives you access to links to free training, right? And you click on this training, do this, then go into the next thing and so on. So it's a very good, I really like this one. I've also used it for my own learning and it's pretty good. So I'll send you this as well so that you have it. And then I also want to talk to you about something called the Machine Learning University. Okay, so this is, Amazon.com, right? So when Amazon.com initially, we started setting up Amazon.com in a big way, we always focused on machine learning right from the beginning. And machine learning plays an integral part of most of the operations of Amazon.com. So those scientists, they came together and said, hey, so we have done a lot of research here, and we need to find a way of teaching our own people as well as the community on what we have learned with our research, building stuff for Amazon.com. And the end result of that is a machine learning university. So you can choose a learning path, and then you have self-service machine learning training from Amazon's own scientists. And if you see here, it's got a number of courses: natural language, tabular data, computer vision, decision trees, and ensemble models. And you can select each of it as its own GitHub repo. So if you go here, so this is the Machine Learning University NLP class. It's got a YouTube video, but look at the course overview. What are the various lectures? Introduction to ML, NLP, the different types of NLP feature engineering techniques and embedding techniques, and then the various types of models and so on. And it's also got visuals. You can also contribute to it. You can directly open it in Studio Lab. So if you click on this, it will open it directly in the SageMaker Studio Lab instance, and you can start playing with it so that you can learn from it, right? So this is really good, MLU. So please keep an eye out for the resources and please do review this, right? Yeah, and this is the tutorial, right? So I've come to the end of whatever I wanted to share with you from a career standpoint. Now I want to, let's say, take a quick pivot and show you some stuff from our upcoming book. So we plan to launch this book at the end of this year or maybe even sooner. But I kind of wanted to show you what that book contains. So let me quickly open it up. All right, so this is the outline of the book. So these are the chapters. So we still haven't done the copywriting or the indexing part. So we still don't have the actual table of contents of the book itself. But these are the chapters. So we'll start with an introduction to the ML workflow and overview of AML services. We'll talk about setting up a data lake and hydrating the data lake using a lakehouse architecture. So this is for you to collect all the data from a variety of data sources, pull that into the data lake for your own needs. The next chapter is future engineering. So it's called predicting the future with features. We kind of kept it funny, the chapter names. The next one is orchestrating the data continuum. So setting up end-to-end data orchestration pipelines to get data to your machine learning models. And then we discuss about algorithms and neural networks. Chapter is called casting a deeper net. Iteration makes intelligence. So this chapter talks about training and tuning. And in this chapter, we talk about autopilot, model deployment, inference, and elastic inference in the cloud, and then some AI services, sensory cognition services, industrial automation services, and finally MLOps. So that's what this book is. But it's kind of going to be pretty deep dive into each of these chapters with live working examples. Also wanted to quickly share with you a sneak peek into the first chapter, which is right here. This is the first chapter. So if you just quickly look through the chapter, so this is the structure, what is the objective? Talk about the evolution of AI and ML, talk about some decision trees and some neural networks and some practical applications of neural networks. And then I've got some helpful tables. So if the ML topic is this is the use case, what framework you can use, and what is algorithm you can use for that. So some helpful tables. And then I also talk about Deep Composer, which uses GAN, as you probably know. And then some approaches for how do you approach an ML problem, what are the different types of learning, as well as when to ML and when not to ML, right? You cannot apply ML just because ML is cool or you want to learn ML. You shouldn't directly go and start applying ML to every single problem out there. So there are some problems which doesn't need ML. You can do regular, rules or whatnot, right? Regular deterministic programming. You don't need probabilistic. So what are the situations where you have to ML, where you don't have to ML? So that's what this table talks about with some examples. And then I introduce the ML workflow. And then I talk about common versus custom ML. And at each step of the workflow, what are the various things that you can do, and so on and so forth. So that's what this does. And then finally, I kind of give some introduce AML on AWS, some of the stuff that we already saw, and different types of problems and what services to use and why you should use these services. And then some examples on, okay, so if let's say you are an analyst or a specialist working for your customer, ML specialist or a data scientist, and your customer says that, hey, here is what I want to do. So here is my problem. So how do you approach it? What are the steps you take? I kind of have laid out some scenarios and walked you through how to exactly kind of approach it and what choices you have. Should you use this? Should you use that? And how, why, and whatnot, right? So some of the scenarios are here. And that's basically the first chapter. So coming out before the end of the year, so please do look me up on LinkedIn and stay connected because all my announcements will be from LinkedIn. And at the initial launch, we will be giving away some books for free and whatnot. So if you're in touch, maybe I can send you some free copies to see what you think, etc. So that's the book itself. Now, I know we covered a lot in this 50 minutes. But I also wanted to show you some fun demos before I leave, because machine learning is not always about some serious stuff. You can also have fun with it, right? So how do you have fun with machine learning? So the first example I wanted to show you is this thing called the simple beer service. So this is something that I built in the AWS Houston office. So this is the logo for the beer service, literally beer. So you have Alexa, right? And what I do is I have hooked up Alexa to a Raspberry Pi. And from the Raspberry Pi, I have an electrical relay that sends signals to a solenoid valve, which is attached to the beer lines in the kegerator. And what happens is that the solenoid valve, as you know, it opens or closes based on electrical impulses. So what it does is I speak to Alexa and say, pour me a beer. Alexa will verify your password. And if the password is correct, Alexa will send a signal to the Raspberry Pi. And from there, it will go into the solenoid valve. It will open up the beer line and beer will pour. So literally taking Alexa and hooking up Alexa to a kegerator. So say, talk to Alexa and it will pour you a beer. So this is a working installation. It's there in AWS Houston, in AWS Indianapolis, I think. And then there are other installations that we did for other our partners such as Accenture, etc. So this is the architecture, right? So this is a Raspberry Pi, and I created a kind of a screens to kind of give some instructions. And this is what you see underneath this, this particular box here. So this is the Raspberry Pi. This is the relay with all the connections and everything. It's a rough hack, but just for the fun of it, right? And this is the overall architecture. So you have the kegerator. I did attach a number of sensors, temperature sensors to check how cold the beer is, humidity sensors. So this is a solenoid valve. So I also have a camera because I double check if somebody places a beer mug before I pour the beer. So if you place a coffee cup, it won't pour beer. You have to place an actual beer mug for it to pour beer. So it uses SageMaker image classification behind the scenes, and it looks for an actual beer mug, right? So then there is ambient noise proximity sensor. I use Greengrass IoT to send these sensor readings to the AWS cloud. And then this SageMaker for beer glass detection. So number of Lambda functions. But basically, so whenever somebody pours themselves a beer, we have an analytics dashboard that kind of shows what are the sensor readings at every point in time, and then how much beer has been poured, how many people are pouring beers. It shows you all the analytics dashboard and whatnot. So that's what this is. So yeah, so this is one example how we can have fun with machine learning. The other example I wanted to show you is this presentation. We also did this at reInvent. But basically, this is, so we used reinforcement learning so we have this a device called Deep Racer. So Deep Racer is a 1/18 scale race car. You can deploy a reinforcement learning model, and it does autonomous navigation of the Deep Racer car. So I took that small Deep Racer car, looked at the results that the autonomous navigation model sends, but I took the results and I hooked it up with a real car, and a Kia Niro. And I wanted to check whether that will drive the Kia Niro also autonomously. So that's what this experimentation was. So we had Anthony, one of our partners, is also an aspiring Mars astronaut, by the way, for the 2030 Mars mission. So let's see if he gets in. Saika is the inventor of Deep Racer. She is an Amazon scientist, and this is me. So the idea was that, so this is this small scale Deep Racer car. What if I take whatever the model that drives this car and try to drive this big car, right? So that was the premise. We also published this paper. It's available in the SAE webpage. We published this paper and kind of walked through exactly how we did the whole thing. But this is the architecture. So if you see here, so you have this camera attached to the small car that looks at a simulated track, and it sends navigation to the servo motor of the small car for navigation purposes. But it uses the OpenVINO inference engine. And so what I did was I kind of wrote this drive, which takes the outputs from the small car, transforms it, and sets up some PID controllers and some steering controllers and braking controllers, whatnot, and sends it to this interface. This is a ROS interface, kinetic ROS interface for this hardware module, which is attached to the OBD CAN of the real car. OBD is onboard diagnostics, right? The controller area network of the real car. You send these signals to the ROS of the real car, and this will translate the smaller signals into a bigger signal for the real car. So that's what this whole thing is all about. But initially, when we started, we did use the PID controllers. It was a bit crazy. But then later we realized, okay, we have to somehow streamline the whole thing. So that's why we added the PID controllers. But I've got some videos of which I want to show you. So these are some of the videos. So this video here is before we added the PID controllers. So this is literally us taking the output from the small car and directly sending it to the big car. And so this is what happened. You won't be able to hear the audio, but you can see that the car is going crazy because the signals, the erratic signals from the small car is directly going to the big car. So it's seeing this is the camera of the small car. It's seeing this simulated track, and it is sending the signals to the big car, to the steering wheel. So that's what this is happening. Right? And it's going back to the steering right here. Okay, so that is without the PID controllers. What we then did was, we said, okay, this is all great. How about we actually experience what that feels like if the steering goes crazy like that? So we were just carefree. So we went to the parking lot and we had Anthony here. He's a safety driver. So if the car goes really crazy, Anthony will take control of the car. He'll go and put his hands on the steering wheel and he'll take control of the car. But until then, his legs won't be on the brake or the accelerator, and his hands won't be on the steering wheel. He'll be like relaxed. So this is what happened. So this is as on the car without the PID controllers. Okay, so I'm kind of sitting here. This is me. I started it, and look at the way the car is behaving. Right, kind of went like really crazy. Super crazy. It started doing donuts, right? Started like a cat chasing its tail. So that's what the car was doing. Very erratic. So we tried once more. Yeah. So this is the second trial, and you'll understand exactly how crazy it was. Okay, look at the steering wheel go on, and it kind of accelerated like really fast. Steering wheel went very crazy. So thankfully, it took control, and we were good. So then we decided, okay, let's go back to the storyboard because something is off. So we went back and we added the PID controllers. So these are the PID controllers that we added for throttle, brake, and steering. And after we did that, so this was the result within the lab. So as you can see now, so here we are showing the simulated track to the smaller car camera. And this is where we are controlling the bigger car. And you can see the steering of the bigger car. You can see it's much more controlled. It's much more stable. It's much more drivable, or it's much more enjoyable, right? And you'll also see that when the track is taking a left turn, the steering will also simultaneously take a left turn. And when the track straightens, the steering will also straighten. So you can see that there is much more feedback going back and forth between the small car and the big car. So that was a very good result that we had with the PID controller. So we once again went back to the parking lot next to the lab, and we then took this model, fit it into the car, and we started driving. And you'll see that's a huge difference between the first time and the second time, right? So now we have already started driving. So you wouldn't even notice that we're driving, but we already started navigating. The car is now driving itself, and it's going pretty smooth, stable, streamlined. And then whenever there was a left turn here, the car was also automatically turning left. So sorry. So as you can see there, so there was a much more bigger feedback and improvement in terms of what the smaller car was seeing as compared to what the bigger car was doing, right? And when we turned left, so when we did the turn left, the car also turned left, but we had to take control of the car because in the real parking lot, there was a big trailer parked right on our left. But in the simulated track, there is no such obstacle. So the car would have turned left. So we had to take control so that we didn't go and crash into the trailer. So that's what happened there. So that is another fun application of machine learning. So this uses reinforcement learning behind the scenes. So as a next step to this experimentation, we actually went to this racetrack right here, which was in Portland. And we took this car. So this is the team. And then we went there. We then fitted the camera in front of the big car. And we had the big car look at the track and then drive itself. So that was very successful, and we published the paper. So just some examples to show you, it's not all about seriousness and learning, blah blah blah. Also have fun, because that's the best way to learn. So with that, I kind of wanted to conclude what I wanted to show you for today. But please be on the lookout because I'm going to send you tons of resources for you to get started with your own machine learning journey. Moderator, I'd like to hand it off to you now.
Yeah, like, do we have questions? Q&A. Would you like to take them?
Yeah, sure. Absolutely.
Okay. So before we proceed to answer the questions, I would like to request the attendees to kindly fill the poll about feedback as it helps us to conduct such more sessions. So the first question is asked by Ravi Mirji. Is Amazon SageMaker similar to Google Colab?
Sorry, what was the first question? I didn't hear that clearly.
Is the Amazon SageMaker similar to Google Colab?
So Studio Lab, SageMaker Studio Lab is similar to Google Colab in the sense that you don't have to sign into an AWS account for you to try machine learning. You get a number of CPU and GPU instances, instance times free of charge in the Studio Lab so that you can try your experimentation there before you sign into an AWS account and go into the free tier. So in that way, yes.
Okay. So the next question is from Srinivasan Meka. Is AWS EMR not part of ML stack since EMR support Apache Spark and Hadoop for big data analytics and Apache Spark supports ML?
Yeah. So EMR is part of our analytics services. So we kind of categorize machine learning services, all services that are part of the machine learning stack there. And EMR, while EMR does help with machine learning, you can also EMR on its own. Without the EMR data, so you can kind of crunch, do map reduce and send it, let's say, dashboards and stuff like that. So you can use EMR on its own. So EMR is part of our analytics services stack. So in the analytics services stack, not only do we have EMR, which you can integrate with SageMaker, we also have Glue for ETL. We also have Data Glue for data distribution analysis and so on. So the number of services in the analytics stack, and EMR is part of that.
Okay. So the next question is from Ashok Puri. I have just begun deploying my deep learning models using Streamlit. How can I transition to deploy it on web using AWS?
Okay. So which environment did you use?
He
using
said
Streamlit. Okay. Yes. So I will send you some resources so that you can learn how you can take models that you have, let's say, you're training in other platforms or you're training it locally, how we can port those models onto SageMaker.
So the next question is from Prasant Sangal. Can we evaluate the accuracy of label data using SageMaker?
Yes, you can do that. So ground truth, within ground truth, you have workflows where you can, let's say you can crowdsource label data, meaning you can use Mechanical Turk, which kind of provides you the option to crowdsource labelers who can label the data for you, or you can set up your own private workforce to label the data. But once the data is labeled, you get confidence scores of the labels, as well as the ability for you to compare and contrast between what the different labelers did, and then review that, and then evaluate that before you accept that label for that machine learning model.
Okay. So the rest questions are repeated only. Okay. Let's take this one. Can SageMaker replace the work of writing codes in IPython notebooks, or SageMaker can only help for less complex projects?
So you can use the example notebooks that are available for a variety of SageMaker use cases. That way, you don't have to write code from scratch. You can take the existing code and replace that code for whatever specific needs that you have. So that's one way to do it. The other way to do it is you can use SageMaker Jumpstarts. So Jumpstarts is pre-built solutions for a variety of common use cases. And what you can do is you can directly deploy those solutions and then once again point them to the data set that you are interested in, as long as the objective and the evaluation metric that you're looking for stays the same. But if you have highly customized work that you want to do, then yes, you'll have to write the code that is required to build your models using the SageMaker SDK. You can use the SageMaker Python SDK, which is Boto 3, or you can use the SageMaker API, which is an abstracted version of it. So, but think of it this way. So when you use low-level code, you may be writing, let's say, lots of lines of code to do a specific function. But using the SageMaker APIs, it abstracts all of that stuff for you within the API. So that way, the number of lines of code will reduce.
Okay. So the next question is from Ramya Krishnan. Hi, sir. I'm new to AWS. Have heard about it before, but never got to use. Seems like model building and training are getting automated. Just have to apply the data, deploys these just a few clicks. So, would you recommend the graduate student to be a business analyst rather than getting hired as a data engineer or data analyst?
Yeah, it's a good question. It depends on your interest. So what's happening is the entire world is now moving towards machine learning because there's a lot of promise and it can do fantastic things. And there are demands for a wide variety of machine learning skills in the market and across personas. So business analysts may, for example, write agile user stories, or they may do, let's say, visualization insights, as well as they may do, let's say, use pre-built machine learning models to run some analysis and get insights and provide those insights to, let's say, a different team and whatnot, right? Whereas a data scientist or a data engineer has got a much more complex role to play. So it depends on your appetite and your interest. If, for example, you would like to be considered as a, let's say, an ML specialist, then I would recommend, let's say, going through the training that's required for a data scientist, because that gives you a full scope of what ML is. And after that, making a call on what you really want to do in your career. So learn whatever you can learn first, and then make the call if you kind of want to do business analysis, which is a very, very high level no code option. Or if you wanted to be a data scientist, which is intensive, code intensive, but it's much more gratifying. It's much more satisfying.
So, Muna Mohammed asks the next question. As a beginner, where should I start using, like, which time should I start using AWS?
As a beginner, I would recommend to start with the tutorials. Use the Studio Lab. You provide your email address, it gives you a link, and you get free access to SageMaker. And there are a number of tutorials that are present, which I'm going to share the links. Start with those tutorials, because as you start with those tutorials, you will understand the basic concepts, and then subsequently you'll yourself start asking questions. Okay, I see I can do that, but how do I do this? And then you'll find more tutorials which will teach you that. And that way, suddenly you'll find yourself, okay, I know these things. Oh, I know how to do that. I know how to do that. So it kind of becomes very evolving.
Okay. Soumya Sahu has asked a better question. Like, have you ever tried weak supervision technique in Studio Ground Truth than active learning?
So what is the meaning of weak supervision technique? Can Soumya please clarify? So when you say weak supervision technique, what do you mean exactly?
Okay, so we'll take up the next question. Let him respond. Yeah.
Okay, I see a question from Sai. How does Textract work? So I think you mentioned Textract, right? Not Tesseract. Tesseract is that device in Avengers movie.
Yeah,
right? It's that blue cube.
Yes.
Blue cube in that Avengers movie. I do not know how that works, because that seems to be an alien technology. But Textract is a service using which you can. It's a machine learning model behind an API. You provide it, let's say, images of documents or PDF files, and it can read the document and give you a JSON structure, which contains, let's say, all the details from the document. So you can go through pages, you can go through lines, paragraphs, you can go through tables, and so on and so forth. So it kind of provides you all those details. So that's Textract. And I actually wanted to show you those console demos, but because we ran out of time, so I couldn't.
Okay. So Sreha Mittal has asked, what training do you recommend for data science journey?
Yes, I would recommend, the roadmap that I showed you, right? The PDF file, which had the list of options for each and every step of the ML journey. I would recommend that. Start with that. And then you can also, I'm pretty sure Analytics Vidhya has got a number of courses for you to get started on your data science journey, as well as refer to MLU, Machine Learning University. Yeah, it's got tons of content as well.
Sir, there's Sanjay Devkar. He has asked, can we have to? Okay, we have to register to use this AWS resources. Please share the link.
No, so the AWS resources, I will probably be sending an email out to Analytics Vidhya with a list of links. You'll have to reach out to Analytics Vidhya to understand how to. So how would you distribute it, moderator? Would you know?
Yeah, we will be distributing it.
Yeah,
they will be receiving the mails. Those are participants. So Soumya Savlu has basically explained the weak technique. It is basically a technique which you create frequent keywords from an text para and inference labels on the basis of that, and inference label on top of it.
Okay. So basically, there are a number of options within ground truth for NLP based labeling, which uses some of the common NLP techniques behind the scenes for creating embeddings and for, let's say, entity tagging, entity recognition, key phrases recognition behind the scenes, so that you can use it for your labeling or for your active learning tasks. So those are all pre-built. But Soumya, if you don't mind, can you reach out to me on LinkedIn so that I understand your question better and answer it? Okay, so yeah, we can. So I think there is a question from Ramakant. Can we handle unstructured data in SageMaker? Yes. So it depends on the use case that you have. When you say unstructured data, if you're referencing to, let's say, social media tweets and text and whatnot, yes, you have some pre-built models on SageMaker, for example, blazing text or word to vector, etc., that you can use. Or you can also use the Hugging Face models on SageMaker. Or the best option for unstructured data in the AWS world is Amazon Comprehend, because it's pre-trained. You can directly use that to derive insights from unstructured data.
Okay. So I think we are already over time. Let me thank you, Prem. Thanks a lot, Prem, on behalf of Analytics Vidhya. I would like to thank you for your time and for delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more some session with you in the future. And I remember, like, when I was in class 7, the AI and ML term intrigued me, made me curious, and like you just made me even want to learn more of them.
Absolutely. And yes, there are some comments on the chat. Is I would love to mentor anyone who's interested in the AML area. So please connect with me on LinkedIn. Happy to mentor anyone who's interested to start their careers or shift their careers into the space.
Okay. Thank you. Thank you.
Thank you, everyone. Have a good rest of your day. Stay safe and enjoy. Bye-bye.
Yeah. Bye.